Walt is a bespoke team of individuals in 5 offices across 3 continents who design, source, install, supply, rent and repair equipment for environmental research. For more than 40 years, we have developed our expertise and experience to bring you best-in-class equipment for soil water and groundwater monitoring and research. Listening to your needs, using our experience and expertise to offer solutions that help you meet your objectives each and every time. Developing the equipment you need to protect the world's resources for future generations. Walt, monitoring your needs.
Greetings. Welcome to episode 1 of the new Walt podcast. We're going to be doing all sorts of things over time. Can't even tell you exactly what they're going to be yet, but we're going to cover all sorts of subjects. We're going to interview all sorts of people, whether that is trying to be educational about certain subject areas that we certainly hold close to our heart and like to work on, and either have solutions on ourselves or work with people who do. Or whether it's meeting the team. You know, there's a lot of expertise throughout the Walt company. And speaking of that expertise, whilst today we're going to be covering nitrates, which just seems to be getting hotter and hotter a subject at the moment, I'm absolutely delighted that we're going to be joined by the man himself. It's Walt Limited, and it's Vincent Walt that started this company 40 years ago. Let's bring him in. Vincent, welcome, sir, to, well, your first podcast.
Good morning. Maybe actually I can start by correcting a little thing, and that is that it's both my wife and I who started the company. So that's a little correction. I think I'm always the one in the limelight, but actually it's not quite the case.
Yeah, fair comment. And I should know that in reality. I've known you for quite a few years myself as well, which is lovely. Before we get on to the original topic of this podcast, the nitrates, I want to really just, as I've managed to get you at this stage, you set this company up 40 years ago. Tell us a little bit about why. What was the motivation? It was clearly some expertise and knowledge you had from the get-go.
Well, Chris, maybe we can go back in time a little bit to my teenage years. I was the 4th child of a diplomat family, so we traveled quite a lot. And really my passion and intention was to find a career either in astronomy or photography. But instead I joined the Navy. And I decided fairly on that the discipline or the restrictions imposed were not quite the type of life that I had intended to lead. And so in those days we followed very much what the parents said. But having left the Navy, I married at a very early age. Realized when the first baby was on its way, incidentally, that was David, now my joint CEO, that I needed to get it more serious. I went to uni, and it was thought that I'd make a very good accountant, and I was recruited in the folds of KPMG, or what is now known as KPMG, used to be called Pete Marwick Mitchell. They were based and still are in Puddledock, Blackfriars in London. And having my superiors think that I had a talent for accounts and banking, I was started off auditing banks, which again was not my thing. So I moved on and helped a friend start a company in soil analysis, and decided that small companies is where I wanted to make my mark. And so both Kai and I started Van Walt Limited now this year, 40 years ago.
This month, in fact, isn't it?
Indeed.
Yeah. It's fantastic to hear. So I'm just going to quickly pick up there is that I'm interested to hear that actually it was the starting the company up with your friend in this environment that then got you to find out more about it and then kindle that passion rather than the passion already being there, hence starting the business.
Yes, indeed. The friend, an Italian, his father had a company which produced soil analysis laboratories, do-it-yourself laboratories. So you got all the reagents and bits and pieces necessary to be able to analyze the soil on site with a little portable lab. And we set that up in London. In fact, the company, the father discontinued the company after a while. But it was great fun, and that got me really into the soil analysis side of things, and we've developed from there into specifically groundwater.
I mean, I find that absolutely incredible because I've known you 26 years, something like that, I would hazard a guess, because obviously David and I went to university together, and that was where I got to know yourself. And so I've only ever known you knowledgeable and passionate about this, and I'd have never have guessed that it was like the other way round, because it just oozes. And of course, when I first joined yourself and you took me through a lot of the onboarding training, the knowledge is just second to none. But the passion, which you can't just learn passion, that is natural, and you have that, and you clearly want to try and help all of these impacts on the environment.
Yeah, yes, indeed. But of course, I'm now old, and it's a time for the younger generations. Hence the reason why David, you and a lot of the other youngsters are now showing their own ambitions and looking to perhaps a new direction, or in a new direction, I mean the expansion of the current business in new fields, and that's pretty exciting.
It is, and I think that's a great opportunity to sort of move on, because whilst it's not necessarily a new area, it's something additional that we've added to the portfolio in terms of a new sensor that just seems to have caught the imagination massively. I mean, when I first heard this, it was nitrates, nitrites, nitrogen. It just a whole big, incredible environment or aspect. First of all, can you succinctly explain what nitrates are?
Oh yes, indeed. Before that, I think we ought to say that the measurement of nitrates is relatively new for us, but it's a very, very old subject. So the point about nitrates really is the N, the nitrogen, which is the important constituent. So that nitrogen is in the air. Of course, 78% of the atmosphere is made up of nitrogen, but it is also what we call a major nutrient. Plants need nitrogen to flourish. So there are three major nutrients: nitrogen, phosphorus, and potassium. Potassium is not so much of interest, but certainly nitrates and compounds made up usually of one atom of nitrogen and some other atoms of hydrogen, for example, or oxygen. Those are the way that the plants will assimilate that foodstuff. And the easiest way for them to assimilate that is through nitrates, but also not to forget phosphates. And the reason we don't talk so much about phosphate is that to date we do not have a method to measure that on site. So it's still very much a wet chemistry analysis. But so going back to your question about nitrates, nitrites, the point is that the plants will take up the nitrogen in the form of nitrates, also in the form of others, but let's specifically concentrate on the nitrates aspect of it. And you can see that most clearly in a field. Look out the window in February, March, and you'll see the farmers top dressing with compounds like ammonium nitrate or calcium nitrate. And you will see from within a couple of days the corn, the wheat greening up substantially, or grass, for example. And so it's a foodstuff. Unfortunately, it has some pretty bad side effects. And those side effects are caused by the fact that nitrates are extremely soluble, and consequently they are mobile. They leach through the soil profile, and they will disappear into groundwater. They will disappear into streams, rivulets, and then down to the rivers, and then onto the sea. So at that point, they are wasted for the uptake of the plant, but they cause other damages. So there are damages or negatives which affect humans' health. They affect the ecology, and overall they affect the environment. So it is very relevant that we need to measure those, because by knowing what is in the soil or by knowing what is in the water, we can actually also fine-tune the application of fertilizers, be it through top dressing as in extensive farming, but also through liquid feeding solutions in intensive farming. If we know what we are losing, if we know where the nitrates are, we can better regulate our fertilization so as to minimize the amount that disappears and becomes bad for the environment. Of course, fertilization for agricultural or horticultural crop is but one aspect of the derivation of nitrates. You have other natural occurrences. Take, for example, farmyard manure. It starts off either as ammonium or ammonia, but through the nitrification process, which is where the bacteria actually make a change in the chemistry, they will be also converted to nitrate. So where there is runoff from a farm, you will also be spreading nitrates, which are of no benefit to any crops. They'll just disappear in the groundwater or in streams and rivers.
Right. Okay. I mean,
and all that is pretty well documented, and I think it probably goes beyond the scope of this podcast. Nitrates provide essential foodstuffs for plant growth, but they have also substantial undesirable effects, and it is those that we need to focus on, and therefore we need to measure them before we can do anything.
So, kind of bringing this puzzle completely together, that obviously with the whole team here at Van Walt, sort of, we got experts in all sorts of areas. Yourself having the challenge of covering all areas, but I'm conscious that one thing that was always, and you kind of really touched on it there, is that if, let's say there's a balance that says, right, you need to add this much of your fertilizer to this much water, and it makes sense that you've got this ratio that needs to be matched, which is all well and good if you're not putting into soil that already is saturated, and suddenly it runs off even more. So we've already been involved in soil moisture, ground water levels and things like that. This now takes it to the other way, that says we're able to measure how much nitrate is, or how much how do you say it? How much nitrate or how much nitrates? Level of nitrates?
I don't really know. I think you could probably use both, Chris.
Yeah. I was just being particular, but we need to measure how much is already there. I think you were almost alluding to there as well, before you go and add more. and that's before we then start working out that there's too much and it's going straight down, it's leachating, and it's getting into where places where it's not supposed to go. But traditionally, I get the impression that it's something that was samples taken and then measured off-site.
Yes, indeed. I think whatever application you make by way of fertilizers to the crop, because of the mobility of compounds like nitrates, you may leach them from top surfaces, but they may still be available within the root zone. Now, in ballpark figures, we're looking at a root zone which extends, let's say, about a meter. And for years and years and years, farmers and researchers have been measuring what we call residual or mineral nitrogen within a soil profile down to typically 90 centimeters. So you would measure through soil analysis, not through electronics, but you would take soil samples from the various horizons, and normally those horizons would be 0 to 30, 30 to 60, and 60 to 90 centimeters. So you could see the percolation and the availability of this compound throughout the soil profile, and on the basis of that, you may have no residual nitrates in, let's say, the top 30 centimeters, but you may have a reservoir from 30 to 60 or 60 to 90, and therefore you might say, I'm going to delay further fertilization because actually I've got enough. And remember that anything which goes beyond the root zone is in fact lost from giving a benefit to plant growth.
And yet it is something that is getting therefore to places we don't want it to be, is causing harm. And I mean, we sort of, in reality, probably barely touched on what harm they can do. But we can have more control over how much is in there. Yes,
indeed. Yeah, we should do that, and we come to the point where there are regulatory forces, and let's take New Zealand as an example. There will be a regulation where if you are discharging nitrates above a certain quantity, you are going to have to measure that if you are a farmer, and you will need to report on that. The idea is not to punish the farmer. The idea is to try and educate them in a way that it will reduce. They can reduce the inputs. And that has a substantial benefit to the farmer themselves, because fertilizers are not cheap. So you can broadcast it in a heavy rainstorm, let's say in a sandy soil. A lot of it will disappear. And therefore, you're putting all this money and effort into doing something which perhaps is not giving you the result that you are looking for.
I kind of almost make it similar to if I'm there particularly, really gasping for a drink, and I've got a cup with a hole in it, and I fill it with water, and then I bring it over here, half of it's gone out, and I'm quickly glugging down whatever's left in the cup. That's kind of almost the effect that they're going to have with their fertilizer. They spend a fortune on this fertilizer, they're banging it down there, and the majority of it's disappearing, doing them no good, and they've just wasted a whole load of their money.
Yes, but farmers are really quite advanced in some techniques. For example, you will have heard of crop rotations, where they may grow a wheat crop, but they will follow that with a legume crop, so brassicas, peas, beans, that sort of thing. Now, the interesting factor about those crops and why they're put in the rotation is that those plant types, the what we call legumes, will actually fix nitrogen from the atmosphere. So they will get their foodstuffs from the nitrogen which is in the air through little nodules on the roots. So that is a way of adding some of this material, some of this foodstuff, for the further crop, so that they will rotate their fields. So that is one way of perhaps minimizing the requirement for excessive fertilization.
I love, and I'm just going to go back to the point that you made there, is that this isn't about penalizing a farmer, because they've got a hard enough job, to say the least anyway, at the best of times. this is about, although you said educate them, it's not just educate them in terms of what should and shouldn't be done. It's educating in terms of they need the facts, they need that information from the ground to know what to do and what not to do. And that really is where we're trying to come at, as I see it from this.
Oh, indeed. I think over the ages, I remember certainly 3 decades ago, where the buzzword or the buzz sentence was farming in a more scientific way, and there's been a huge amount of research done on this, and in this country, in Britain, there are wonderful organizations such as Rothamsted Research, but not least organizations like ADAS, which were government organizations, and they've done a tremendous amount of work on this nitrates, but also phosphates and potassium. So they have tables of suggested application rates following the analysis of soil, which gives them the data they can work on in order to calculate what fertilization is needed.
Do the levels fluctuate? The nitrates levels fluctuate in an area?
Well, the soil matrix is very complex. There is really no such thing as a homogeneous soil. But you will have soils with large particles, sand particles, which are very big particles, and so things will leach very quickly. But you can go into heavy clays where the particles are very fine, and therefore will retain everything much more. So yes, of course, it depends on the soil type when you're estimating the retention of that particular sediment type when you're trying to make a decision on fertilization.
I guess where I'm coming from, that in my sort of like still relative layman's terms, certainly compared to yourself, is that it's all well and good going and getting a sample to then do the analysis on, but that's what it was on, that day at that time that you grab the sample. If it fluctuates over a period of days, weeks, months, whatever, it doesn't give you the real thing. So we need to somehow be able to keep a watching brief in effect on that.
Yes, from the point of view of environmental research, of course, we're looking at the second step, the second phase. So you've used up, you've fertilized, you've applied the nutrients to the soil. But I think at the moment what we're concentrating on is when that is passed, phase 2 is you've got these compounds which are going somewhere, and water flows downhill. So whatever you have will ultimately be drawn away either through the groundwater or into rivers, for example. So that we have to measure them and therefore give us access to what impact those compounds are given is extremely important. So I think maybe if I may just go back to the subject of the measurement of nitrates, we are in a lucky position these days that we are able to measure that with relative ease. So whether it is to take a water sample and take it back to the laboratory for analysis, or indeed, as we can talk a little bit more today about being able to measure on site. So where we have a device which can accurately measure the nitrates. And the importance of this is that, and you alluded that to a few moments ago, we are no longer in a position where we're just taking a sample which gives us a momentary result, and it may change in an hour's time, in a day's time, in a week's time, where we have a sensor installed that can monitor more or less in real time. We can actually see what is happening and the changes of these compounds through the aquifers or through the rivers.
100%. And, I'm going to leave that as a teaser at the moment for us, because there's a reason why we're talking about that, is that absolutely we have nitrate sensor now available for our customers that does measure these things real time, straight to a dashboard, an online dashboard at your desktop, to be able to see all that information live for you. Now, I will come back to that, but quickly before we move on to that, if we're measuring it, Vincent, are nitrates something that you can prevent, reduce, remove if you find out there's too much there?
Well, I think if there's too much there, you can't go back. So,
Okay.
Whatever is causing the excess of nitrates, it's there. But what you can do is to try and minimize the impact for the future by altering what it is that you're doing. And farming is just one aspect of this. Of course, we need to look at other parts of our industry which generates nitrates. Effluent, for example, is another thing to look at. So whereas farming has an easily explained cycle, shall we say, where you're going from either farmyard manure or inorganic fertilizers, you also have to look at the fact that nitrates are actually created or dispersed by other vehicles.
Yeah, absolutely, and it's not just that it comes from other areas. It can affect so many different things, whether it's planning permission for things to happen on site. It's amazing how much this can impact things that we probably take for granted day to day as well.
Yeah.
Let alone, we won't go into things like fines or anything like that. It can get really, really nightmare. So it's not something that you can remove there, but you can change the practice that you stop adding to that nitrate mountain. And the fact that it's soluble, it can naturally reduce over time because you're no longer adding to it. I think by the sounds of it, that's the key thing. But we need to understand that we need real-time continuous monitoring. And that now bringing us onto it, because I think we've kind of dabbled around the information, which I make no apologies for. I just find it captivating when I'm chatting with Vincent and we get to hear all these the facts and what's going on that I didn't really think about enough. I know plenty of you that are listening or watching will probably be laughing at me because you do this for all the time, but it's now being able to have something there that's going to give you that data real time, left on site. It couples with our Van Walt data hub and the Van Walt Connect, the Connect being the dashboard that feeds Vincent all that data to them real time at their desk.
Yes. So ordinarily with these devices, in fact, not just nitrates, but any of the devices, we normally sample at a rate of once every 15 minutes. Now, there is no standard for doing that. You can increase that frequency, you can decrease that frequency, but you can imagine you get a tremendous amount of data flowing through the system. So you can watch the graph go up or go down as time progresses. So yeah. It's those data which are giving us a huge understanding of what is the level of nitrates. Is it increasing? Is it decreasing? And here you have indeed the picture. It doesn't look particularly pretty picture, but it's a tube, and you dangle that in a stream or a river, or indeed, in fact, if you measure groundwater through a monitoring well, and you connect that by cable to our telemetry system, and that telemetry system will energize the sensor at the sampling frequency. As I said, usually we set that at 15 minutes, but that can be altered. It looks simple, but in fact, it's very sophisticated, and
that's the best way to be, isn't it?
Yeah, you shouldn't underestimate the technology that goes underneath the hood, so to speak. Just briefly, for those who are technically inclined, how does it work? It's a spectrophotometer, which is which is pulsing a xenon light through the sample at a specific wavelength, and that wavelength is captured, and the level of nitrates can be derived through the internal algorithms into milligrams per liter. And that is what we are interested in.
And for those of you, by the way, if you're listening to the podcast, I know you'll be going, what picture? That's fine. We also have this video, so make sure you go to the Van Walt YouTube channel as well, and you'll be able to actually watch this conversation with the pictures as well. But for the podcast, it was just showing the sensor, which was easier in a photograph, Vincent, because it's not a small device, is it? It goes there. And can you give us an idea of how this... I don't know whether this is a fair question, how it would be deployed, because I get the impression we can have it in well or even surface water.
Yes, I think you can, as long as you dangle it in water by in some way, it'll start measuring. The item has to be submerged. I think that's important. Usually when we're talking about surface water, which may mean streams, reservoirs, rivers, you would still put it within what we call a stilling well. So a stilling well is just a piece of tubing. It can be even drain pipe, and you suspend it in there. That's really done more for the protection of the device itself, so you don't get stones, twigs, and or rocks damaging it. And you would position that within the stream or the river. In groundwater, you would have a monitoring well, which takes you down to the groundwater, and you would dangle it from the wellhead down so that it is submerged. It is a long device. It's around about the 50 centimeter length, but that's also because it has an integral pump which is used to clean the lens surfaces at certain frequencies. We squidge water at high pressure from the pump onto the lens for 10 seconds every 3 hours. That keeps the algae, bacteria away from the lens, so we can get as accurate result as possible.
That just sounds so cool.
I would say that, and what is important is that this particular device, it tops off at 50 milligrams per liter, 50 ppm. So it's important that we're looking within the range from 0 to 50. That is the range in which we're interested. In certain application, it'll be much higher than that. But Chris, you might use this, for example, we've had a request from a drinking water company, and they are interested because they want to test that there is no nitrates in the water that they're going to sell to the public. So it has various applications, and we're pretty excited about this product.
Absolutely, and I'm not surprised. Also, as well, like, I get the impression that the accuracy as well is quite significant, and I think one of the areas that I started getting understanding that you mentioned about the drinking water company is that this isn't just about that there is, it's clearly nitrates are present. This is when it could just be tiny little traces of it, and we're still able to read that to great accuracy.
Yes, in most cases, and we tested it here, for example, on tap water, and I'm pleased to tell you that our tap water contains virtually no nitrates. I think I'd like to say a little bit about where does this come from? Where has the research been done to create this particular product? And it's manufactured by a company called Hydrometrics, which is a New Zealand company. And nitrates in New Zealand are a really hot topic. Hydrometrics is a subsidiary of Lincoln Agrisearch, which indeed is part of the University of Lincoln down the South Island in New Zealand. So it's gone through a very, very long research phase to get to where it is. And it's had its improvements, which make it a very stable product, a very reliable product. and a product which for sure will find a place in many applications.
Yeah, absolutely. I mean, we only launched it last week, and we've just been inundated with people that need to find out more than this. And I'm not surprised. As I say, is that we can take the sensor, connect it to our Van Walt data hub, feeds the data to the Van Walt Connect dashboard. And the reality is, with that data hub, Vincent, is that we're able to even add additional sensors to that could understand other elements that could be impacting it, whether it's the weather station. So it's like, okay, so when you're getting that information, how much rain had fallen in the last day. I don't know. I'm just thinking of ideas off the top of my head that we could be doing that. And that can also be additional sensors that can be feeding into the data hub.
Yeah, the data hub is a very sophisticated telemetry system, so it will accept sensors which speak many different languages simultaneously. So you're right, you could connect, for example, a rain gauge to it or a weather station. You could add level measuring devices, but you could also add devices which measure water quality, such as pH or turbidity, or indeed a host of different sensors, and all of those can be added to the data hub. So you could get a very full pictures with a lot of parameters, including nitrates.
If somebody is currently or in the future going to be involved with the something that requires the need to measure nitrates and report real time and continuous, how can they find out more? I mean, I guess it's they need to come and speak to us and let us understand what are you looking to achieve.
Yeah, the way we work, we have some people here who are mentoring on the product, and that'll be people like Lewis and Jess and Rosie, and in fact, indeed yourself, Chris. So that's the first point of call, is to drop us an email. We'd like to understand your project because we need to know the requirements of your project. So if you come to us and say, well, we expect, indeed, as we had in from our Spanish office, where they were looking at nitrate levels in excess of 120 milligrams per liter. Well, we know we can't do that. So it's important to work within the range of the equipment. So we need to understand the project. So we need a little chat, which can be done over video conference or over email. Once we understand the requirements of the project, then we can make a proposal. And I think for our listeners, I think we ought to point out that at Van Walt we offer the full service from the beginning, but we will also do the installation, because with all these things, installation is critical. You need to do a proper installation in order for the device to work reliably and robustly. So in most cases, we do the installations ourselves. So we would come to site, we would look at the site, make sure that we've covered all angles. So we have to measure things like network signal strength. We also have to see whether there are constraints because of security, or because the water is very deep or it moves very quickly. So that would be done through a site visit, and then we would proceed to the installation. And we always follow that through, and all the devices which are on our systems are actually monitored daily to make sure that they're responding and sending data the way they should be doing.
Absolutely. And for anybody who wants to find out more, I have put it on the screen for those that are watching the video version of this, but it's www.vanwalt.com/equipment/nitrate-sensor. So vanwalt.com/equipment/nitrate-sensor. And you'll find out information and an easy way to that include all sorts of technical bump for you as well. And please do get in touch. The team will be able to have a conversation with you to start with, whether that's phone, email, Teams. Site visits can happen to work it all out, to fill any gaps that might exist, and then, as Vincent says, manage the project with you as well. Equally, by the way, one of the things that's key to say is that something that I'm doing with a growing number of our clients is that if this is something that you are pitching as a project, so you doing it, so to your customer you are pitching, and this kind of needs to be involved. If you want us to work with you and assist on that, in that pitching process, if you need to present to your potential customer that this is what's going to be in place, we are more than happy to come and work with you to present our technology for you, not just the nitrate sensor, any of it at all, because then it just makes sure you're not trying to take the secondhand information. We are more and more working with our clients to help that process for you. So please don't shy away from asking if that's going to be of any assistance to you as well. At the end of the day, we're all here for, I'm going to say the greater good, but that gives me a flashback to a particular film. But we know what I mean, the greater good. It's going to help everybody. Incidentally, one of the other things that I wanted to make sure that people can have a look at is vanwalt.com/projects. vanwalt.com/projects. We have a growing number of the projects that we're involved in. And it's not just growing in terms of number, that obviously is always growing, Vincent, but it's the diversity is just, it never gets dull, does it?
No, it doesn't. And some are very straightforward and some are very complex. And we do these all over the world. We have offices in New Zealand, in South Africa, in Spain, and in Northern Ireland. So we have different flavors, shall we say, and all these countries provide a different challenge, particularly on the insulation side. David was involved in a big project in Kenya just before Christmas, for example, and that brought new dimensions to our project file. Yeah, it's worthwhile to look at those projects. In fact, the good thing about the project, it shows the capability of the devices. So you can say, well, yes, I can potentially use that for an application for which I'm tendering or in which I am involved.
And it does go further and further, and whether that is soil gas as well, we're involved, whether that's shallow, deep, sub-slab, active soil gas, portable landfill gas analyzers. We've got a number of wet environments that we can get involved in. Water level, we know, soil moisture levels, anything that can measure environmental, agricultural, archaeological, which seems to be a really hot topic at the moment as well, that we're losing the moisture and we're losing a lot of treasures. Meteorological parameters such as water level, pH, EC, redox, electrical conductivity, temperature, dissolved oxygen, rainfall, hydrocarbons, nitrates, water flow. Wow, it goes on and on. The point being is, have a conversation with us. It's the best thing I can say. At the end of the day, we will, if it's not something we know about, it's not something we can help with, we will be the first ones to tell you, and it will probably be that we'll tell you who to go and speak to, because we're all there with an objective, and that is to try and overcome these challenges that we're facing all over the world. Hence, we've got offices ourselves all over the world. I love it, and Vincent's probably there smirking, seeing the enthusiasm in me that has grown. I was brand new to this last year. I'm a professional motorsports commentator, and David and Vincent and Tracy approached me to join. We've got a very exciting product, another product that we're launching this month that we'll be bringing to you soon as well, that is affordable and easy telemetry. And that's kind of going to be my real baby. And I would never have thought that I was going to sit down and say to friends in the pub, I'm now involved in all of these kind of things. And yet, Vincent, I can understand why you went from not necessarily being a passion to being, dare I even say, obsessed with it all now. It's easy to get into it, isn't it?
Yes, it is. Yeah. Yeah, we're very lucky to be in the sector.
It is. Right. Well, I think that, is there anything else that you want to add about this, Vincent, that we haven't covered?
No, I think not. I think we've been going for a while, so I think probably we should give people a rest. But follow this channel, because there will be different podcasts run by different people about different subjects. So we're very excited about this vehicle of communication, and we hope you like it. And thank you for listening or watching.
Absolutely, and thank you for joining us, Vincent. It's been an absolute honour. We'll have the main man back on this show plenty, don't you worry. We'll be grabbing you on, even if it's kicking and screaming, Vincent. You'll be on to share your pearls with us. The idea is that, as I say, the video version of this will be on our YouTube channel. We will have the audio podcast that will be going out. Our main platform is Buzzsprout, but that feeds it into whatever method you use to listen to your podcasts, whether it's on the Apple, Spotify, Google Podcasts, whether it's on your Alexa device, whether you put your headphones in on your phone and take the dog for a walk and just listen to these podcasts. They're all there available, and you can turn on the notifications so it'll notify you each time there's a new podcast to either stream or download. In your car, on those journeys, stuck in the traffic, you can listen to certainly this time, me and Vincent rattling on about things that I think you can hear we're rather passionate about, and there's an awful lot of knowledge that I'm yet to share. We're hopefully going to have external guests involved over the episodes as we progress. Watch this space. There's going to be all sorts. So from us here at Van Walt, thank you very much for listening to the first podcast, and we'll see you on the next one. Thanks, Vincent.
Thank you, Chris. Thanks, everyone.
Van Walt is a bespoke team of individuals in 5 offices across 3 continents who design, source, install, supply, rent, and repair equipment for environmental research. For more than 40 years, we have developed our expertise and experience to bring you best-in-class equipment for soil water and groundwater monitoring and research. Listening to your needs, using our experience and expertise to offer solutions that help you meet your objectives each and every time. Developing the equipment you need to protect the world's resources for future generations. Van Walt, monitoring your needs.